In this section, we're going to be talking about quantum numbers. So, might sound a little weird, but quantum numbers are just really a way of classifying each individual electron so that they can use a set of just 4 numbers and then be able to tell, okay, we're talking about this specific electron in this atom. The atom may have over 100 electrons, so it is important to be able to know how to identify each individual one. So, quantum numbers, again, are a specific set of numbers that describe one electron in an atom. And they can actually use just 4 numbers in order to describe a single electron. So you can think of them as like the mailing address for that specific electron. Okay, so in this case, the state has as many electrons as, think of the atom as the United States. Okay, so the atom, the United States, contains as many electrons as that atom has. So if we're talking about calcium, United States has 20 electrons in it. Okay, and then you're talking about the state. All right, so the state narrows it down. Okay, cuts out a bunch of the extra electrons, and you're narrowing it down to just a specific energy level at that point. Okay, we'll get into that a little bit more. And then you narrow it down to the city within that state, and then the street. Now each street only has 2 electrons. Okay, and then the house number tells you which of those 2 electrons you're looking at. Okay, so you can think of it like the mailing address, where you go from the country down to the state, to the city, to the street, and then the house number. So first up, we have the principal quantum number. So this is basically the state. Okay, it is symbolized by a lowercase n, and it indicates the energy level occupied by that electron. Okay, so this is basically what row is the electron that we're talking about in. Okay, on the periodic table, what's the energy level? That can be a number between 1 and 7. Okay, so it really depends on where that atom is on the periodic table as to what the max number can be. So if it's a hydrogen, it can only have a max N of 1. Okay, because it can only go into that first energy level. Right, but as you continue going down the periodic table, you can potentially add in more N values. Okay, because the energy levels, there are more and more energy levels in that atom. Okay, so the principal quantum number is looking at all of those different energy levels and is picking one of them and tells you, okay, this is the energy level that we're going to talk about. Next up, you have the angular momentum quantum number. So this is like the city. It is symbolized by L. Okay, so it's a little weird. It'll look like a 1 a lot of times, but that is an L. It indicates the shape of the orbital. And now, how many shapes do we have for the different orbitals? 4 of them. Okay, so there are 4 potential L values. They can be a number between 0 and n minus 1. Okay, so L values in orbital shapes. 0 is an s orbital, 1 is a p orbital, 2 is a d orbital, and 3 is an f orbital. Okay, so those are relatively easy to remember. You just, again, put your orbitals in order, s, p, d, f, and then just count from 0 to 3. Technically, you can have an L value of 4. We just haven't found any elements that use that kind of orbital. I believe it would be a g orbital, is what they've said. So again, we don't have anything in that level. Now, when it says n minus 1, okay, that is referring to basically if you have, say you have hydrogen. Okay, well, hydrogen is max n of 1. Okay, well, hydrogen only has an s orbital, so it can only be an L value of 0, which is n minus 1. 1 minus 1 is 0, so that is your L value. Okay, now if you move up from there, all right, say we have an n of 7. Okay, So your L values can be anywhere from 0 to 6, all right? Because an N of 7, an energy level of 7, has every type of orbital that we have. So 0 through 3. Okay, now we don't have 6, we don't have a 5, we don't have a 4. All right, so basically L at this point can be anywhere from 0 to 3 because that is what we have at this point. Okay, so you're going to see L values of one of these 4 here. Okay, and then it just directly corresponds to one of these orbitals. All right, next up we have the magnetic quantum number. Okay, this is basically the street. Okay, so it is symbolized by m sub L. This indicates the orientation of an orbital around the nucleus. Now remember, each orientation, like we learned in the last section, can only hold up to 2 electrons. Okay, so just remember, m sub L will only have a max of 2 electrons. Now, m sub L is kind of a little bit different. It can range between negative L and positive L. So if your L value is 0, okay, then your m sub L can be negative L to positive L. So that one has to be 0, okay? Now that makes sense because if you remember, an L value of 0 refers to an s orbital. And how many orientations does an s orbital have? Just the one. Okay, so m sub L is 0. It's the only orientation. Now, if you go up to an L value of 2, okay, your m sub L could be negative 2, negative 1, 0, 1, or 2. Now, if you remember, L value of 2 refers to a d orbital, which has 5 orientations. And look, you have 5 different m sub L values. Okay, so that lines up exactly with what we were talking about in the last section. Okay, so your m sub L values. If you have an s orbital, okay, so an L of 0, I'll write that on there, your m sub L can only be 0. Now, if you have a p orbital, so it means your L is 1, you can have from negative 1 to positive 1, okay, or negative L to positive L. Can be a negative 1, a 0, or a 1. Moving up, if you have a d orbital, so you have an L of 2, can be negative 2, negative 1, 0, 1, or 2. And finally, if you have an f orbital, or an L value of 3, you have 7 different possible orientations. So negative 3, negative 2, negative 1, 0, 1, 2, or 3. Now, because I'm not making you memorize the different orbitals in especially D and F, okay, you're not going to have to know which number corresponds with which orientation. Okay, you just have to know that they're different orientations and what the possible values of the m sub L's can be. Okay, and now finally we get to the spin quantum number. So this is the house number. And if you remember from the very beginning of this video, I said that basically there are only 2 houses on each street, okay? Which means that the spin quantum number can only be one of 2 values. It is symbolized by m sub s, and it indicates which direction the electron is spinning, either in the positive direction or the negative, okay? So the 2 possible values are positive 1/2 and negative 1/2. So really doesn't matter which one, okay? It'll be one or the either. One or the other. There we go. One or the other. Okay? So basically, if you are describing both electrons on the same street, okay, so they have the same m sub L value, okay, the same L value and the same N value, once you get to the m sub s, one of them will be the positive 1/2, the other one will be the negative 1/2. Alright, so kind of looking at this here, we have our N, our L, our, let's see, oh, those are number of orbitals, so different orientations. Okay. There we go. This is, let's see, number of electrons possible. So basically this is just this times 2. And then total electrons possible in that energy level. Okay, so this is just adding these numbers together. So, looking at our quantum numbers, we just have our N and our L here. Alright, but if you have an energy level of 1, the only possible L value or sublevel orbital type available is an S. Okay, which means that there's only one type of orbital available, and or one orientation available, and it's going to hold a max of 2 electrons. You go up to the second principal energy level, so N equals 2. Now you have a different type of orbital present. It's a p orbital. Okay, and it has 3 different orientations which can each hold 2 electrons. Okay, so that's where you get the 2 and the 6. So you have 8 total possible electrons available in the second energy level. Okay, you move up to 3. Now we have a d orbital available, which has 5 orientations. So now we've added in 10 more electrons possible in the third energy level. And then we move up to the 4th. Okay, now we have another S, a P, a D, and an F now. So we add in 14 more electrons. Okay, and if we move up to 5, this is where you get the extra orbitals coming in. Okay, so they're basically adding in a G and an H here. Those would be the next orbitals. Okay, so this is like an L of 5. No, an L of 4, sorry. L of 4. Get that erased. There we go. So that would be an L of 4, and this would be an L of 5. Okay? Now, again, as it says down here, these orbitals are not used in the ground state of any known element. So basically, we haven't found enough elements to fill any of these type of orbitals. Okay, but these are theoretically possible. Okay, so if you remember, we were talking about the lowest energy level that you can have for each orbital. It's 1s, 2p, 3d, 4f, 5g, and 6h. Okay, now you'll notice here, okay, that one also has a little star next to it. It's because we do not have anything in the 6F block. Okay, so if you remember, the F block is that one piece that's kind of on the bottom of the periodic table, and it's got those 2 rows. We would only have a 6F if we added another element underneath the first one of the F, or the 5F. Okay. Alright, so this is a lot of theoretical here because we don't have these electrons yet, we don't have these. So right now we don't have the full number of electrons that could possibly fit in that energy level. Okay, so yeah, so take this with kind of a grain of salt. It is a lot of theoretical stuff in this image right here. Alright. So this is looking at the different type of orbitals you can have. Okay, so you have your 1 energy level. Okay, L value can only be 0, which is why there's only 1 row for this. What in the world? Okay, that's why there's only 1 row for this. All right, the M sub L, it should be an M sub L there, is, you know, remember, negative L to positive L, so that one has to be 0. And then its orbital name is 1, which you get from N, and then S, which you get from your L value. Okay, and L value of 0 equals S. Okay, number of orbitals, because it is an S, is 1, and that is also found here. Alright, so we're going to pause here and pick up in the next video, if I can find my mouse. There we go.